Hello, students. In this class, today we are going to see the topic computer tomography. Okay. So, what is this computer tomography? So, it is a new method. Okay, it is a new method of forming images from X-rays. Actually, it was introduced by Godfrey Hounsfield. He's a British physicist. He got a Nobel Prize in the year 1979 for this invention. Okay, so it is being referred to as this computer tomography. What's the other name for it? Is a computerized axial tomography, or else we can say it as computer transmission tomography. In simple words, we can say this as computer tomography. So, what are all the principles behind this? We are going to see. Mainly, it is based on scanning of your multi-directional scanning of the object that is the object of interest that's being kept under study. From this, the multiple data are collected. Or else, what we can say this is the measurements here are usually taken from the X-rays which we transmit through the body, and this contain the information about all the constituents of the body which are in the path of the X-ray beam. So by using this multi-directional scanning, you are able to collect the multiple data. Okay, what is this mathematical basis that's hidden behind this is that is the basis of producing an image, or else this particular cross section of this body here. One of the measurements, that is you're taking measurement along the total, or else you can measure the attenuation, that is the total attenuation, and these are taken along the rows as well as the columns of a matrix. So you can easily compute the attenuation of this matrix elements, okay, by suitably by means of intersection of these rows as well as the columns of the matrix. Usually here the computer performs your mathematical calculations. Okay, the computer performs your mathematical calculations, and it only obtain the information. So this information, how you are presenting it is a conventional form. You can present it in a conventional form of what we can say it as being a two-dimensional picture, or else a slice. Okay, that we call it as a slice. So, as I told you earlier, there is a mathematical basics. Okay, there is a mathematical basis of how you are constructing the image. So, here you are making use of one simple calculation method, which we call it as a back projection reconstruction method. Okay, back projection reconstruction method. So we will see how we'll move on to this method. Okay, here there are several steps are involved here, and we have to arrive at several estimates, that is your first, second, third, as well as your final estimate, or your third, first, second, third, fourth, as well as your final image you're finally obtaining, which we call it as your slice. So we'll move on this. Usually what we can say about this is here, um, as I told you earlier, the attenuation values which you are taking across the surface of your slice. So this can be, you can compute from the externally measured attenuation factors. Okay, even though the computer which you are using creates a different angles. Okay, we are make use of different angles other than this 90-degree to the your body axis. So and it solves this higher order matrices, which is of the order of your that is almost your 2 cross 2 matrix. So that will be taken into your account, and we'll see one by one what is the manner that's being involved in the analysis of your mathematical calculations. And so your first step is being, you have to suppose you are taking your actual attenuation attenuation values, right? So you are normalizing it to 0, and it's being represented by your 2 cross 2 matrix, okay? And your okay, so your second step is how you are going to calculate your first estimate, okay? How you are going to calculate your first estimate. See, here each number, okay, each number which you are representing, yeah, in your matrix, or each of the number that is present in your matrix represents the attenuation, okay, attenuation of the space, that is the exact space where it is being located, where, okay, that will be that each number in your matrix represents what is the attenuation of the space that is being exactly located. So here see in your you see, ah, here not, you see, here you have one zero value, okay. So this is being, that is in your upper right corner. You are having one zero value, and it is actually a measure of this attenuation, okay. It is actually a measure of the attenuation that is being present at the upper right hand corner of your matrix. You see, then your second step, we'll move on to your calculation of your first estimate. So here, usually you're measuring these attenuation values from outside, okay, from outside, which you're seeing along that's being seen along the rows as well as the columns, okay. Here we are calculating in such a way, you see, such that your sum, so okay. You see the sum. You see the sum. That is the 2 plus 2, which is being your 4. Okay. So there you are calculating. That is your in the previous step. That is the 2 plus 0, which gives the sum 2, and here this 2 plus 2, which gives your the sum 4. So so this is your calculation of your first estimate. Okay. Then you see, then how we'll move on to your um, second estimate, okay. Usually the second estimate, you are usually obtaining it from the values which you are measured across the columns, such a way, you see, that gives this sum 3. You see your step, what is your matrix which you get in your step 1, that is your 2 comma 0 as well as your 1 comma 3, okay. See, when you say take this, that is the 0 plus 3, so that gives you the sum 3, okay. So your 3 comma 3 3 comma 3 matrix, okay. That is your values you are measuring across the columns. In your first estimate, you see, that is your step 2. When you see step 2, you see, so usually in your step, your first step 1, what is your matrix is 2 comma 0 and 1 comma 3. While you're calculating your first estimate, what you are doing is you are taking these values along your rows, okay. Rows, what's the value you are having? That is your 2 comma 0 and 1 comma 3. So if you add this 2 plus 0, what is the sum? The sum is 2, okay. So you are putting it in your first row. What is the value? 2 comma 2, okay. That's the value you are getting. What's the value? You see, 2 comma 2. What is your first estimate? That is 2 comma 0, 1 comma 3. That is your step 1. Then how you are arriving at your first estimate? That is 2 comma 2. You are adding the numbers along the rows. That is 2 plus 0, which gives 2 comma 2, 4 comma 4. So if you add these, as I told, you have to add along the rows. That is In your previous matrix 2 comma 0 1 comma 3. So if you add 2 plus 0 you'll be getting 2 2. You are putting it here. So if you add your when okay, this 2 plus 2 which gives 4, okay, which gives the sum 4. So you are getting the first estimate as 2 comma 2 4 comma 4, okay. You see. Then how you are obtaining your second estimate is that, as I told earlier, what is your matrix in your step 1 is 2 comma 0 1 comma 3. Okay, so if they add the 2 comma 0 1 comma 3, so there in your step 2 you are adding along the rows. Here what you have to do is you have to add along the columns. Okay, that is, since it is 2 comma 0 1 comma 3, if you add this 0 plus 3, what you are getting? You are getting the value 3. So this is what the value you are arriving, that is 3 comma 3 comma 3 comma 3 matrix you are getting. Now what you are doing is you have to add this matrix to the first estimate. What is your first estimate? What is the matrix you get in your first estimate? That is 2 comma 2. Okay, 2 comma 2 4 comma 4. Okay, that you have to add it with this 3 comma 3, that is 3 comma 3. So if you add 2 plus 3 you are getting 5, that is 2 plus 3 5, and this 4 plus 3 you are getting 7. So this is the your estimated value. You are getting it, so you're trying to get in your second estimate. Okay, then if you have to move along your third estimate. So here what you're doing is the third estimate you're obtaining it from the values that is measured along the northeast diagonal. Okay, measured along the northeast diagonal. As I told you earlier, what is your first matrix? That is 2 comma 0 1 comma 3. If you see the diagonal, what are all the elements present in your diagonal? Okay, what is the diagonal? You see, can you able to see here? Is your diagonal elements. Since it is here 2 comma 0 1 comma 3 matrix, the diagonal elements are 2 and 3. Okay, the diagonal elements are 2 and 3. Okay, the third estimate can be obtained from the values you are measuring along the northeast diagonal. Okay, and you are getting this value as, that is your 2 comma that is your 2 comma 1. Here you are not taking the attenuation. Here you are not attenuating your upper right corner, so you'll be getting this value 2 comma 1 1 comma 3 matrix. Okay, here you are not taking into account your attenuation factor. So what's the value you are getting as 2 comma 1, and it is 1 comma 3. Okay, now what you are doing is your you have to add your second estimate with your third estimate. What is the second estimate you have already obtained is your 5 comma 5. How you get this? That is, you are adding this, that is the 2 comma um, 2 comma 2 4 comma 4. If you add it with your, that is the 3 comma 3 3 comma 3 matrix, then you will be getting this 2 plus 3 5, and this 4 plus 3 7. Okay, so this 5 comma 5 7 comma 7, so that you are adding with your 2 comma 1 1 comma 3. So here you are taking only the diagonal values. Okay, that is the northeast diagonal values of your, that's the matrix it's being in your step 1. So you are adding with it. So if you add these 2 cross 2 matrix, what you are getting is 5 plus 2 7, and this 5 plus 1, if you add it is 6, and 7 plus 1 gives 8, and this 7 plus 3 gives 10. Okay, so that's the way you are getting your third estimate. Okay, so previously the main thing is that first your step 1, that is being your first matrix, that is your 2 comma 0, that is 1 comma 3. So there your step 1, there you are taking into account your attenuation factor of your upper right corner. Okay, so while calculating your third estimate, you are not taking into account that attenuation. Here you are taking this values that's being present along your northeast diagonal. So okay, northeast diagonal, if you are not attenuating it, that is the upper rightmost corner value, you'll be getting this 2 comma 1 and 1 comma 3, that you're adding with your 5 cross, that 5 comma, that is your 5 cross, that is your 5 comma 5 7 comma 7, that's that matrix. Okay, which you are obtaining from your second estimate. Okay, so that each value you are adding with this, that is 5 plus 2, and this 5 plus 1, and this 7 plus 1 and your 7 plus 3. So finally you are arriving at this value, that is 7 comma 6, and your 8 comma 10. That's the way you are arriving at your third estimate. Then we have to see, you see, you have to move on to your fourth estimate, right? So the fourth estimate, you see, simply I get struck. Fourth estimate you have to calculate. You see, how you are actually got struck with our slide. Please. Actually, we have to move on to your, I don't know why we got struck with the slide. Okay, wait. Okay, we'll be getting here. So after that, we have to move on to where, you see here, fourth estimate. How you are calculating your, okay, fourth estimate is that you are obtaining, you can obtain the values here. There, as I told, in your, while you are calculating your, um, your third estimate, you have to take the values along your northeast diagonal. Okay. So here what you are doing is that you are taking the values, the sum of the values, okay, along your, here you have to take the values along your northwest diagonal. Okay. So what's the values along your northwest diagonal? So that is 2 comma 3. So there you are getting the, what's the value in your northeast, northwest diagonal. Okay. Northwest diagonal. So you are having this 1 comma 0. Okay, there what is the in your previous step there you are having this values along the northeast diagonal, that is being your 2 comma 3. Here you are taking the values along your northwest diagonal. Okay, so that is your 1 comma 0 and you are taking the sum. Okay, so that what is your sum is 2 plus 3 which gives 5. So 5 comma 0 1 comma 5. So that's the matrix you are getting. You have to add this with your third estimate in order to get your fourth estimate. Okay, so what is your third estimate? That is 7 comma 6 as well as your 8 comma 10. Okay, so if you add that, you have to add it with your 5 comma 0 and this your 1 comma 5 means what you are getting. You are getting this your 7 plus 5 gives 12 and your 6 plus 0 gives 6 and your 8 plus 1 gives 9 and your 10 plus 5 gives 15. Okay, so this is the value you are getting as your fourth estimate. Okay, that's your fourth estimate, and we have to arrive at your final image. What you are doing is you are normalizing your fourth estimate. Okay, what you are doing, you are normalizing. You are normalizing your fourth estimate to 0 by subtracting 6 from each element. You are subtracting 6 from each element. Okay, actually what you are here having, that is your 12 comma 6 as well as what's the value. What's the value of your almost of your fourth matrix is that it is almost, that is your 12 comma 6 and 9 comma 15. Okay, that is the value you are getting in your fourth estimate. What is that? 12 comma 6 9 comma 15. So here from each element you are subtracting the value 6. Okay, and what you are getting is if you subtract 6 from 12 you are getting 6. Okay, that's your first row element, and the second element of your first row is there it is 6. If you subtract 6 from 6 you are getting 0. Okay, so that's being your second element of your first row. So coming to your second row, here what the element you are having in your fourth estimate is that it is the value is being 9. If you subtract 6 from 9, what's the remainder you are get? What's the difference you are getting is 3. Okay, that's being your uh, second row first element. Okay, then there what is the value you are getting in your fourth estimate is 15. Okay, it is 15. So if you subtract the 6 from 15, what is the value you are getting? You are getting 9. So this is the way you have to normalize your first estimate to 0 by subtracting each element which you are getting from your fourth estimate. Okay, what's the value you are getting? 6 comma 0 as well as your 3 comma 9. Okay, so what you are doing is you are there here you are dividing for simplification. What you are doing is you are dividing this value. Since you see all you have to the simplification, what you are doing, you see all these values in your that we after normalizing your fourth estimate to 0, what all the values we are getting, it is divisible by 3. Okay, so for the, in order to get a simplified one, what you are doing is you are dividing each element in this after normalization by 0. So if you divide each element by 3, each element by 3, okay, you are, in order to get your final images. So what's that? If you divide 6 by 3, you are getting 2, and if you divide 0 by 3, you are getting 0, and if you divide 3 by 3, you are getting 1, and if you divide 9 by 3, you are getting 3. So this is the way you are getting your final image. Okay, now we'll see there. So this is the mathematical calculation that's being that's behind your method. That is the mathematical calculation that is behind this method, which we use for this computer tomography. Okay. Now we will see what's the how the setup, then their setup, how which they use for this CT scanner. We are going to see. You see, when you look at the diagram, can you able to notice? Um, you see the patient, okay, he's being present inside this and he's being surrounded by this x-ray tube as well as the detectors, and there is a detector scanner, and there is a high voltage supply, tube position control. You're having one timing control from the detector and the scanner. You are having there being the control as well as the data bus which is being connected to your microcomputer. From there you are having one CRT, okay, your cathode ray tube, that is being your output unit as well as the storage device, and it's also a camera. Yeah, you see, where when you look at your timing, okay, timing circuit, okay, so it's almost here you are controlling your anode voltage as well as your current, okay, that's the x-ray beam current. So it's the controlling voltage is being in the range of your kilovolt as well as your that is the x-ray beam current is almost it's of the range of milliamps, okay. So the entire thing you are controlling it through the control bus. You see, they are being connected to the control bus of your dedicated computer. So then you have one high voltage DC power supply. You see that being drives your X-ray tube. Okay, so you can mechanically rotate it along the circumference of the entire setup. Which you call it as a gantry. So here the patient is lying inside. So he's in a tube through the center of your gantry, which is being the center of your gantry. Now here the X-rays pass through the patient. What it does is that's how it's being partially absorbed. Okay, so the remaining X-rays which are not being absorbed, so they'll impinge upon your detectors. You are keeping it. So how many detectors almost you are keeping it is at the range of about almost 1,000 radiation detectors are being fixed around um, the patient or else your circumference of your gantry. Okay, so here how the detector responds, so it's almost its responses you can relate it to the how much or how many protons that impinge upon the detectors. Okay, so and accordingly your tissue density, how much based on your tissue density only, how much proportion of this x-rays that will penetrate through the your tissues and how much they are absorbed. Okay, so and how much it's being absorbed by your less dense tissues as well as the difference between your the absorption by your high density tissues as well as your less density tissues. Okay, so here as I told some that there is the X-ray photons that's being impinged. Okay, so upon your detectors, so that so these photons are again they are converted to as scintillations. Okay, the computer here which you are using it here, what's its use is that it senses what's the position of your X-ray tube, and it accordingly it will samples the output. Okay, even this output of your detector which you are placing it along the diameter of your X-ray tube. Okay, so here you are doing one calculation, and it's almost based on the data which you're obtaining from the complete scanning that's being made by your computer. The output unit you are able to get here, as I told you, have on CRT. Okay, that is a visual image. That's almost being a the transverse plane cross section of this patient. So that's being you on your CRT. That's your cathode ray tube. It can also, if you want, you can also photograph it using the camera. That's if you need a hard copy record. Okay. Now, when you talk about your present day machines, almost you're able to get the slices even with a very high resolution. Okay, of about 1 to 2 seconds. Okay, with the very high precision you are able to obtain. Then uh, coming to your applications part, what else we can say? Um, where this it's almost you can find out what are all the um, imaging, this sitting imaging, it's almost diagnose the various what else the damages or lesions that's being present in your central nervous systems. Here, your what are the techniques that you are using under this head is that is cysternography as well as the ventriculography. So that's this the technique that is almost in brain scanning as well as your contrast enhancement as well as this dynamic imaging. So here you are also making use of one another, that is the C2 stereotaxy. That's another one more new technique which you will be introducing here. And mainly they are useful in finding out of these the brain injuries as well as your vascular lesions, as well as in oncology, as well as that's being used for primary malignant lesions of being present. Means you're able to find out using this, as well as the in the finding out of your degenerative diseases. Okay, so coming to the diagnosis of orthopedics as well as in your bone tumors, so its extent it's almost being clear. So here it's mainly if there is any damages in your periosteum, cortex medulla, or else in your soft tissue as well as in a neurovascular bundle, that can also be found out using this. And the dimensions of your bone, okay. So, and also using this, the doctor is able to come to a conclusion where the patient is suitable for prosthesis. Okay, that's also almost depends on your CT imaging. And also it's used in cytology as well as in determination of this. What is the nature of your lesions? That is where it is a solitary plasmocytoma or the metastatic or else your spondylotic changes is, or anything other else that's being present. That's what also you are able to identify. And coming to the thorax part, it is very useful in the screening of your people who are under the high risk, that is the chronic smokers and who are in the at the risk of getting cancer. That is the thing that is in the that's as a earlier detection of your lung cancers. Okay, and also some, if there is anything something serious or something lesions being present in your malignant cells, or else what you can say, or else in your differential diagnosis of your pulmonary nodules. Okay, or non-malignant, that is based upon your, that is the density variance that's being present in your that is the CT scan. It's very useful. And also finding out your lung lesions as well as your mediastinal tumors. And also it differentiate, if there is any differentiation between your malignant as well as your chronic pulmonary inflammatory lesions. So that's also provide a clear cut, or a clear cut outskirts will be provided by your this CT scan image. Okay, and also additionally it also provides the evaluation part of your, or if there is any enlargement in your, that is the mass of this lymphanodal or enlargement, or else your mass lesions that's mainly present in your mediastinum or else the hilar region. Okay, then coming to this abdomen as well as the pelvis. So the CT imaging, so it's produced an enlarged image. Okay, and it also being used as a diagnostic tool in finding out this percutaneous nephrostomy, as well as if there is a biliary drainage. So you're making use of this CT guided fine needle aspiration, as well as for the cytology. Okay, even in your inaccessible parts also, that is the dynamic imaging. Okay, that is the after contrast, so it's very being helpful in the evaluation of the vasculatory lesion as well as your differential diagnosis of your malignant as well as your non-malignant lesions, and as well as the pseudiaphragmatic space as well as your peritoneal cavity lesions can also be evaluated. Okay, coming to the neck part, so it is useful in assessing your malignant lesions of thyroid or also in your larynx. Okay, if you are preferring for to plan for any surgical approach. Then coming to your radiotherapy planning, here Along with the routine treatment, you can also add upon this. Okay, that is the CT. That's your first stage. It's being involved, as well as the here the image is being transferred to the treatment planning. So only for what are all the areas which you have to mark out for this radiotherapy, as well as the so how much dose you have to distribute. So and also this while you're taking this radiotherapy, along with that you can make use of the CT studies. Okay, that is how much is your volume of the tissue that's being irradiated, how much it can be reduced. Okay, so thereby you can save this any unwanted radiation that's the normal tissue that's being exposed. So nowadays, your CT scanning, you are incorporating this 3D simulation facilities. Okay, that's what we can say about this computer tomography. Okay.